Hello, welcome to my Precalculus playlist. This is the beginning of the topic of essentially functions and manipulating functions as well as treating them as objects and seeing how they may interact with one another. Sort of an informal way of saying that. And, we will probably understand what that means in the future, and I might just bring that up again and again. But anyways, today we'll be focusing on defining really two things and seeing how one of them is more useful in the context of what we're trying to study. And what are those two things? So let's jump right into it. So we're going to talk about two things. The first one is going to be called a relation, and the second thing is going to be called a function. Now, I'm sure there are a lot of you who have seen this word right here, function, but maybe you haven't seen too many mathematical texts with relation, especially if you're maybe a young student. I don't see when you would see a relation, but both are very general terms, but have significant consequences. But they're very similar in terms of defining them. What do I mean by that? Well, so a relation, so we'll start by defining relation. So a relation is a correspondence between two sets such that each member of the first set corresponds to at least one member in the second. All right, so let's quickly look at a couple of these words. So this is the definition of a relation, and what we want to look at are specific words like sets. So sets are just, if you don't know, are objects in math which hold objects in them. They just hold things. They can be anything, numbers, they can be names, it can be literally anything that you can think of. And so sets in math, and in particular this context, we're going to mean numbers. But again, you can also replace that with other things depending on the context. So a relation is a correspondence between two sets, and in this context, numbers. So two sets of numbers, such that each member of the first set corresponds to at least one. Let me emphasize that, at least one member in the second. And that's super important because you have to recognize the language here, right? At least one, right? This little phrase we can change, and a lot of times this happens in math where we can change one slight part of the sentence and mean a completely different thing. And that's exactly how we're going to define function. We're going to use this exact definition, except changing this phrase. And so what is a function? Okay. So a function is yada yada yada. It's a correspondence between two sets. So everything that we have up to there, up until the box, corresponds. So we're going to say that it's two sets such that each member of the first set corresponds to exactly one member in the second set. Okay, so that's the main difference between a relation and a function. So as confusing as this may sound, functions are relations, but not every relation is a function. Okay. Of course, you might be able to come up with an example of this. What's an example of a relation which is not a function? Let's say I have, let me write down a set, maybe 1, 2 as the first set. And I have maybe a second set, maybe 0 and, I don't know, 5. Oops. Okay, so here are 2 sets, and I have some relation. So I'm gonna call that relation between the 2 sets R. Okay. And so how do the elements correspond to each other? So in the definition, at least one member in the first set. Such that each and every, you can sort of interpret this as each and every member of the first set corresponds to at least one member in the second set. So this relationship is going to be defined by, so I'm going to send 1 to, I'm going to send 1 to 0. And I'm also going to send 2 to 5. And just because I'm defining this relation right now as we speak, I'm also going to have 1 be sent to 5. So 1 can go to 0 and it can also go to 5, but 2 also goes to 5. And so this is an example of something that's not a function, but it is a relation, right? So how do we check that, right? First of all, there's 2 sets of numbers. Every member of the first set corresponds to at least one member in the second. Is that true? So I look at 1, one has a home, or 1 is getting sent places, and then 2 is also getting sent places. And in each case, it's at least one member in the second set. So as you can see, you can increase the number of members that you're sending to. And so you're allowed to do this with relations, but not with functions. Now, what are some examples of functions, right? What are some examples of functions? We've probably seen a bunch of them, in algebra, for instance, maybe f of x is equal to x squared. Okay, so here's a function, and it's a function because, again, using that same definition, every element, and so again, we want to specify, it's a little hard to talk about why this is a function without defining what my sets are, like what's contained in them. And so usually we use the convention of the real numbers, which is written this way. And so for every real number that I choose to put inside of this function, I always just get one single output. Okay? And that's true. And you can see that with simply a graph. Okay, so x squared looks something like this. And if you remember from geometry, the geometric interpretation of this function is it's a parabola. It has parabolic qualities such that no matter which x value I choose, there's always going to be some y value. And not only that, there's no discrepancy. There's no element that I'm going to choose where, let's say I chose 9, right? Up here, it's going to be 81, and that's it. There's no other solutions, right? When I plug in 9 times 9 is always 81, and it's not going to be something else. There's no way. A lot of students may get confused about the fact if I choose -9, it's actually the same as 81. It's still a function though, because I've only chosen one input. So for every input, like that's the subject, right? Math is language. So I'm choosing 9. So for every 9, there's only one 9 on the number line. There's going to be that 181. Okay. Yeah, they may have the same y value, but that's fine. It's still a function. Because for every, this is one way I look at it, is like for every number 9, again, there's only one number 9 on the number line, there's only one output, and that's completely true. It says nothing about what the output is. It could be anything. But yeah, hope this helps. And look out for the next video on probably functions again, and we'll do some more examples.